Alright, so now it's a good time to go ahead and import the rasterio library. Again, if you do not know how to install the rasterio library, we have already created tutorials. I'll put the link in the description so you can actually follow it and get it installed quite easily. Right, so I can again maybe run the whole thing just to make sure that everything runs quite well. And now just keep in mind that I have changed the number of points to 5. So now what we can do is we can go ahead and read in the raster actually. So what we can do is we can say that DEM equals to rasterio.open, and over here we have to provide the path, and along with that we also have to provide the mode, which is R, and I have kept the DEM in this folder, so I'll just provide the path for it like this. It's dem.diff. Alright, now we can run this to see everything looks fine. Alright, next we can assign two variables, the row and the column. That's going to be dem.index. Now over here we have to provide the latitude and the longitude. Now instead of doing it like this, our objective right now is actually to sort of create another column over here and then plug the corresponding elevation values based on this latitude and the longitude. So what I'm thinking is that maybe instead of doing it like this, I can again write a for loop. Let's say in this same thing, and before that I can create another column called elevation. Again, I'm going to assign an initial value of 0 for everything, but later on I'm going to actually extract the elevation from here and then fill it into that table. So let me do the indentation for this. So what this is going to do is actually during each iteration it's going to read in the DEM, and I think we don't necessarily need to do that. Instead we can actually read in the DEM before it proceeds into the loop. And over here we can start assigning the indexes. So alright, here you are supposed to provide the longitude and the latitude of each row. Now before proceeding into this step, maybe let me highlight this, and if I just say print and row, you can see that what it does is actually it's printing all the information of the rows in this manner, but you can isolate and then maybe call a specific column by its column heading. Let's say if you just want to print let's say the latitude, in that case you can see that it's actually printing out the latitude. And if you want to print the longitude, yeah, you can see that now it's printing out the longitude. Now if I open the variables explorer again, what I need to do is I need to identify from the raster what is the corresponding raster index, which happens to be the corresponding which corresponds to this particular latitude and longitude. So what I'm going to do is I'm going to provide this longitude over here. Now I can actually get rid of the comment, and similarly I can provide the latitude as well. Now I can maybe go ahead and create another variable called dem, and that's going to be equal to dem.read, and we can just run this one just to make sure that everything works fine so far. And over here what we can do is, now since we are trying to populate this elevation column with the corresponding elevation value, I can use the same script which I used over here, but this time it needs to be changed to elevation, and that's going to be equal to DEM data, and over here I have to specify the row and the column, corresponding row and the column. Alright, now if I run this and if I go to the variables explorer and if I open this, you can see that we already have the elevation values populated now. For example, the starting point, it says that the elevation is 395 meters and the ending point is 400 meters. Now what we can do is we can actually go back to our ArcGIS just to do a quick check whether these values are correct or not. So as you can remember, our starting point was somewhere over here. Yeah, this pixel is actually our starting point. So what I can select this identify tool, and if I click over here, you can see that the pixel value is 395 meters. Similarly, if you go over here and try to take the final pixel, you can see that the elevation value is 400. The points which corresponds to the middle points, actually we are not able to exactly pinpoint right like this unless we split it into the same number of segments as we did in using the script. But now you can see that actually those two values are correct, the 395 and the 400. That actually proves that the script is working quite well. Now if you want, you can even first have a look at this GDF PCS geopandas geodata frame. Yeah, so this is how it looks now. And if you would like to maybe do a quick plot just to see how the section looks like, maybe I can create another variable called profile, and I would like to extract maybe only these two columns, because now this is a geopandas geodata frame, so I just want to extract only those two columns which corresponds to edge distance and elevation. The horizontal distance, and this is the elevation. So now I have a pandas data frame called profile. So you can actually do a quick plot, profile.plot, and over here you can specify the x and y columns. Now over here in the x column is going to be edge distance, and the y column is going to be elevation. And the profile looks just like this. So you can see actually the x column, the x-axis is showing you the horizontal distance from left to right, and this is how the profile basically looks. Now if you would like, because this is actually only for 5 points, maybe if you would like to do that for a multiple number of points, let me put this one over here, and let's say now if I increase the number of points to something like 50, yeah, this one I have to put it out from the loop. And now let me go ahead and run this. And now you can see actually the profile looks quite detailed. Before you saw that when I only have, let's say, 5 points, the profile looks like this. But the more number of points, let's say even you can put 200 points, doesn't matter. And then if you try to check, you can see actually the elevation profile looks quite detailed right now with 200 points. Just let's maybe try to put around 1000 points and see whether there's a big difference. Yeah, you can see that there's a bit of a difference when you use 1000 points, but I think using around 50 points would be a good place to maybe conclude. Alright, now I guess you got the basic idea what we can do with this kind of a tool, isn't it? I'll just get rid of this plotting option, because maybe we'll keep the plotting options for a later stage. Even if you would like to double check how the profile looks, maybe what I can do is I can just use this interpolate line tool to create the profile. And as you can see, if I compare the profile side by side, you can see that it's almost the same, but this one looks a bit more detailed because it's basically picking up all the pixels. but in this case we are actually controlling how many pixels that we need to pick. But as you might guess now, it's not actually impossible for us to match this one. You just have to keep on increasing the number of pixels that we pick. So I guess that was overall was a quite successful tutorial, and now let's move into the next stage of actually extracting the data for a higher number of sections. Now for example, you can see that I have one shapefile over here called cross sections. So instead of using just one section, maybe now I will actually focus on extracting these sections and then probably generating the sections, and probably focus on generating the profile for each and every section over here. Alright, so for that I actually have to go to the sixth line which I had, because the whole script which I developed was actually only for one single section. But now instead of using one single section, what I'm going to do is I'm actually going to import this shapefile, which is this cross sections shapefile, because so far we have been dealing with this test cross section, but now we are going to import this real cross section. So how that's going to happen is that let me change this variable to cross sections, and now the shapefile is going to be cross-sections.shp. So for the timing I will comment this whole thing out. Alright, now I can just go ahead and run this script, and what I can do is I can just first have a look at this cross-sections geopandas geodata frame. Now in the previous section what I did was I actually focused on just one row, because that one had only one attribute. But in this case you can see that it has how many attributes? It has 58 attributes, including the 0. So what I'm going to do now is I'm going to actually iterate through each and every row. That means I'm going to sort of read in each and every section, and for each section I'm actually going to perform this operation that we did over here. And maybe if someone wants to extract the data into a CSV or something, you can do that, or if you want to just create a figure and then save that figure, that's also actually quite possible. So what I'm going to do is I'm just going to actually create another for loop which can sort of read in through all of these lines. So that one we can do just by creating another for loop for index row in cross sections, and from here we can create one more variable just to take the ID of the cross section. So I'm just going to create another variable called maybe cross section ID, because for each iteration I actually want to sort of capture this ID, and that one is going to be row, similar to what I explained to you guys before. And in this case it's going to be access ID. And now we can sort of go ahead and indent this, because now this should actually come under this major for loop. Alright, now you can see that we don't have a variable called line. And now since we have gotten rid of the previously had shapefile called line, this one is actually no longer relevant. So now you have to extract the starting coordinates and the ending coordinates of each cross-section ID using this row variable. So I can actually do a replacement like this. It's going to be row.geometry. Just make sure you put it in square brackets, and over here as well. Alright, so before going into the next section, I would just like to maybe highlight this whole thing and then comment it out, and just run the script only for these few statements, these few lines of code, just to make sure that it's working properly. Yeah, now you can see that we don't have any error, so that we can sort of go ahead and include this part as well. Alright, now what's happening over here is that it's actually iterating through each and every row over here, and it's detecting the line string, and it's extracting the starting coordinates and the ending coordinates for each case. It's going to do this for XS0 all the way up to cross section 57 over here. Alright, so for each iteration now I would like to extract the information that we need. Basically, I would like to extract the information corresponding to the x and y axis of which is required to basically develop a 2D drawing of a cross-sectional profile. So in this case, as you can recall, the x-axis information is actually given by the h distance, the horizontal distance, and the y-axis information is basically given by this elevation. Alright, so during each iteration, let's try to find a way to sort of extract this information, because now we have almost reached the final part of the tutorial. So it's just up to us to, creatively find out a way to sort of store the data that we need. Right, now what I can do is actually from this geodata frame, I can extract just the 2 columns which I need, which corresponds to the horizontal distance and the elevation, and save that into a pandas data frame. Alright, so for that what we can do is we can create a variable called maybe x, y data. Basically that's xy data refers to the xy data that we need in order to plot a 2D cross-sectional profile. And that's going to be equal to the 2 columns h elevation and the h distance and the elevation. Alright, now we can maybe go ahead and run this one and see. Yeah, apart from this warning, we actually did not get any error, so actually the code is working quite alright. And if you want, you can even go ahead and you can have a look at the different elevation values against the h distance. Now, this variable basically refers to the final cross-section of the list of sections that we had, because it's referring to the x57 section, because whatever you get over here for this xy data variable is basically the information that gets recorded during the last iteration, which corresponds to the final cross-section. So now we will try to find a way to maybe save this information. What we can do is we can save this information into a CSV. It's quite simple. We can go to xy data. We can say xy data to CSV, and over here we can specify a path to which we would like to save the CSV and also the file name. Now maybe I would like to go back to my working folder, and let me create one folder so that I can sort of collect all the cross-section profile information into that folder. Over here you can see that maybe we can create a new folder, extracted sections, I think something like that. And now I can copy this path simply and paste it over here. And for the file name of each file, since I record the access ID, the cross-section ID over here now, what I can do is I can basically plug this cross-section ID as the file name to my newly created CSV file, isn't it? And this one is going to be the cross-section ID, which is a string, so that we can actually do these string operations of adding strings together. And this one followed by .csv. Now if you're not sure how this might look, what you can do is you can always type this into your IPython console and see whether it actually looks like a proper path or not. Yeah, I think it looks like a proper path. As you can see over here, now all the information that gets printed are actually corresponding to the final loop, which happens to be the information of the 57th cross-section over here. So this looks alright. So now what happens is during each iteration, it'll sort of detect the file name, the cross-section ID name from here, and it'll save it into that folder based on that given cross-section ID. Alright, now what we can do is we can just go ahead and run this script. As you can see, it might take a while, but now if I go back to the extracted sections, you can see that it's actually already generating 39, 46, 48, 57. Yeah, Now all the sections are done. Now if I want to check the cross section number 0, yeah, now you can see that we have the edge distance and the elevation over here. So if you would like to do a simple plotting, what you can do is you can just insert and you can just do a simple line graph, or maybe, yeah, something like this. Yeah, this one is corresponding to the XS0 section. Now as you can see that you can increase the number of points, which will actually make the lines a bit more smoother. Now that's up to you, because the objective of this tutorial was basically to teach you how to do this process. Maybe I can have a look at another section, cross section 33. Yeah, I can do a simple plotting over here. Yeah, this is how the section looks like. It looks like this part probably refers to the river channel bed. Alright, in addition to this, what you also can do is you can even directly do the plotting in Python itself, and then you can actually save the cross-sectional profile graph directly into a folder for all the sections. Right, so now if you want to create individual plots for each graph, each cross-sectional profile, you can even do that. So first make sure that you have imported the matplotlib library. As plt, and over here you can simply say, maybe I'll comment this out. Creating plots for each cross-sectional profile. You just have to define the plotting characteristics over here. First we define plt.plot, and over here what we are going to plot is basically the x values which are corresponding to the edge distance, and similarly the y values which are corresponding to the elevation over here. Alright, and now since we do this now because we are actually trying to use the matplotlib library, the capabilities of matplotlib library. But if you just want to directly plot the pandas data frame, you actually don't have to use the matplotlib library exclusively. But now since we're actually trying to save the figures, we do the plotting in a bit of a different way from what I showed you before. So that's why the script actually looks like this. And now we can actually define the plotting characteristics, such as you can define an x label. So in our case, the x label is basically going to be the distance, which is given in meters. We also can define the y label, and the y label is going to be elevation, that's also in meters. And we can also actually specify a grid. If someone is trying to maybe look at the values, we can, this kind of guiding grids might come in handy. And also we can define a title, plt.title, and as the title now I would like to directly put this title over here as the title of the figure, because during each iteration it will actually assign the corresponding cross-sectional ID as the title, so that we don't have to worry much about it. And finally we can say plt.savefig, and for this maybe I can save it to the same location along with the CSV files, but just have to make sure that we change the extension of the file to an image format like PNG or JPEG or something like that. And if you just want to display the images during each iteration, you can just say plt.show, and I guess that's about it. Alright, now what we can do is we can just go ahead and run this, and as you can see over here, it's actually generating figures for each section, which might take a while. If you open the folder over here, you can see that actually the figures are getting generated as well. Alright, what you can do now is maybe have a look at these figures, and this is how each of those figures look. You can even have a look at the figures like this. So now we created the script actually to extract the cross sections corresponding to each and every section over here. For example, XS10 is actually this section, so this is how the profile looks. Similarly, for each increasing section, you can see that how the cross-sectional profile actually looks for each specific distance, each specific horizontal distance. So I guess that concludes the tutorial. I'm sure this tutorial might come in handy for you guys if you're interested in doing this kind of work frequently for your day-to-day stuff. So if you like the tutorial, don't forget to subscribe to this channel, and also don't forget to give a thumbs up. That'll actually help us immensely to make our work reach as many viewers as possible. So thanks a lot for watching, guys. If you do have any questions, you know what to do. Just comment them down below and we'll get back to you as soon as possible. So I'll see you again with another exciting tutorial just in a couple of days. Take care, guys.